Hey grade 11s, let's use a cast diagram to solve the given problem. So the given problem reads as follows. It says in the figure the coordinates of P is k and 3. So they gave us the y coordinate of P, which is 3, and k is something that we're going to have to find. And we're also given the angle POX is alpha, and the length of the line segment OP is 5 units, right? So because we're dealing with a cast diagram, it's just worth noting it. So here in this quadrant, cosine is positive. Here all trig ratios are positive. Here sine is positive, and here tan is positive. Also, we're also given the length of line segment OP, and this here is 5 units. So we can form a right triangle knowing that P is 3 units. P is 3 units above from the origin and k units away, negative k units away from the origin. So there is the location of P. P is k units away from the origin, negative k units, and it's positive 3 units up. So the first question says determine the value of k. So to find, because we have a right triangle here, we can use Pythagoras theorem, which states that the square of the hypotenuse, OP squared, is equal to the sum of the squares of the other two sides, which is k squared plus 3 squared. And we have OP squared, which is 5 squared, is equals to k squared plus 3 squared. This is 25, is equals to k squared plus 9, so 16 should be k squared. If we take the square root on both sides, here we have plus minus 16, therefore k should be equals to negative 4, or k should be equals to positive 4. So we reject the second solution because k has to be negative. The coordinate is in the second quadrant, so k is negative units away, as we can see here. It's measured with respect to the negative x-axis. The second question wants us to find tan of alpha. So tan is a trig ratio. Tan is a trig ratio, is opposite over the adjacent side, and the opposite side to the angle is 3. You can see the opposite side to this is 3, whereas the adjacent side is negative 4, because we found k to be negative 4. So the next question, 2.1.3, we need to find cos of 90 degrees plus alpha. So if we use our reduction formulae, we know that cos of 90 plus alpha should equals to minus sine of alpha, and sine of alpha should equals to opposite over the hypotenuse. Opposite side is 3, hypotenuse is 5, so this is equals to minus 1 times 3 over 5, and this is equals to minus 3 over 5. And the last question, 2.1.4, wants us to find the size of alpha. So we are given sine of alpha to be 3 over 5. So therefore alpha should be equals to sine inverse of 3 over 5, and this is equals to 36,87 degrees, correct to 2 decimal places. But remember, this here is a reference angle. If you look at our schematic, you can see that alpha is an obtuse angle. Knowing that alpha must be an obtuse angle, as we can see on the schematic, we cannot accept this angle, the reference angle, as the final solution, but we can take advantage of reduction formulae, knowing that sine of 180 degrees minus alpha is equals to sine of alpha. So therefore sine of 180 minus 36.87 should be the same as sine of 36.87. So therefore sine of 143.13 degrees should be equals to sine of 36.87. Because these ratios are equal, it means that alpha should be equals to 143.13 degrees, or alpha should be equals to 36.87 degrees. And we accept this solution because alpha is an obtuse angle.